Dear students, welcome to this session. In this session of the lab program, we are going to discuss lab program number 14. Develop a program using pointers to compute the sum, mean and standard deviation of all elements stored in an array of n real numbers. So in this particular program, what we have to do is we have to use the pointers, that is the first thing, and we have to find sum, mean and standard deviation of a certain set of numbers that is stored in an array. Already we have seen how to use the array. So array will be having those n real numbers. So we are going to take not only integers, all the real numbers, floating point and integer, both kind of numbers. So first we will understand what is sum. Is very straightforward. Sum is, it is addition of all the array elements, and mean, okay, mean is the sum of all the elements of the array and divided by the total number of elements, that will give the mean value. Now standard deviation. So we will just see some of the concepts that will be used in this program. Is mean is there is a formula. I will show you the formula, and in case of this particular program we have to use the pointers, and pointer is what? Pointer are the variables which store the address of another variable. So pointer will point to the address of some other variables. We can use the pointers to store the address. So we will also see what is the pointer, and we will understand what is a standard deviation, how it is calculated. So this is the array A, and we know what is an array. Array is a collection of similar data elements, or you can say it is a collection of either integers or floats or chars. So here we have a array A, and this array is having a size of n. The number of elements in this array is n, and the values that are stored in each of these index locations is d0. D0 is a value, d1, d2, d3. And how do we normally access these array elements? We use the index. So the first data element is accessed using the index 0. So how we access that? A square bracket 0 will give me this data, that is d0. And how to access d1? A square bracket 1, that is a of 1 will give me d1. So on a square bracket 2, index 2, we access d2, and so on. So how to access the elements of an array? Using the index values. Using index values we can directly get these values. And we know that this is array is how it is stored in the memory. Is it is stored in a contiguous memory where these particular elements will be stored next to each other. Suppose this is we have an integer, and integer takes 2 bytes, then we will have 2 bytes, next 2 bytes, and next 2 bytes, so on. And these memory locations, these particular array element where it is stored has a address, and that address would be in the hexadecimal format, and using that address we can access the array element. Suppose if we know the address of d0, if we know the address of this particular memory location, I can directly access this data element. One way to access this data element is using the index, array index. Another way to access that array element is using the address. And in the next address location, that this is another location, in the next address location we will have the next data element, and in the next location we will have the next array element. Suppose if I know this address, if I add 1 plus 1, and automatically it will know what kind of a data element. It will point to the next memory location. If I say this address plus 1, I will get the next address, and so on. That is how we can access these data elements using the address. So you can think with a similar analogy. You have a row of houses, right? House 1, house 2, house 3, house 4, house 5. How I can access? Each house will have a unique address, right? One house number, let us say it is apartment. This is apartment number 101, 102. So using 101 address, I can directly access that particular apartment. Similarly, array elements can be accessed using the address, hexadecimal address. Now, whenever we in C programming, whenever we when we declare an array, that name of the array itself is the starting location, that gives the starting memory location of that particular array. If I say A is actually pointing to the starting location of that particular memory. Now we have the array elements D0, D1, D2, D3 and so on. Let's say it is, example is there is a value of 10, 20, 35, 46 and so on. How to calculate the sum? Sum is equal to D0 plus D1 plus D2 plus D3 so on, Dn minus 1. And how we can do this? Since we know it is an array and its size is n elements, n is the number of elements, I will loop from 0 to n minus 1 and I can access this and I can add. Only difference here is, instead of using the index, we are going to use the address. And what is the initial address? Initial address is stored here, and when I read the first element, which is at initial address A, then I will take this value, and after that I will increment the address by 1. So whatever the address is here, plus 1 will take me to the next location. I can get the value of that data element, and I will keep on increasing the address up to n elements. So I get all the data elements, I will add it, I will find the sum. How to calculate the mean? So here I have taken it as represented as x bar because I am going to use it in the standard deviation. Mean is also represented as x bar is equal to sum of all these values divided by n. N is number of elements. How to calculate standard deviation? Standard deviation is equal to square root of, then we have d0 minus x bar square. So first element minus mean whole square plus d1 minus x bar whole square plus d2 minus x bar whole square, so on dn minus 1 minus x bar whole square. So we are going to take the difference of each element with respect to the mean and we are going to square it, and we will take the sum of all those squares and divide by the total number of elements, and we will take the square root of that, which will give me a standard deviation. This is how we are going to calculate the sum, mean and standard deviation. Now we will go back. First one is we will see how to declare a pointer variable. Second one is how to access the pointer variable and how to move the address from one to next memory location. We will see that in the program. Okay, so the program it starts. I'm going to need the hash include stdio.h standard input output .h header file for all my printf scanf functions, and also I would need the math library. So why I need math libraries? I need to find the square root. So there in the math library there is a function called lowercase sqrt using which I can find the square root of any number. So I will include the math library hash include angle brackets math.h, then main method, a pair of parentheses. This is the starting of the program, that is the open curly brace. Now first is I want to have all the real numbers, so I will declare it as a float, and where the n real numbers are stored, they are stored in an array. So I will declare an array A and square bracket 50. 50 is the dimension. We can have maximum of 50 numbers in this array of type float. And next you can see asterisk ptr. So what is this? This is nothing but the pointer declaration. So pointer, so if you want to use the pointer, first we need to declare them. This is how we do that. So ptr is the variable name, ptr is the pointer variable name, and it should be prefixed with the asterisk or the star. So always a star should be there, followed by immediately, there is no space in between, followed by the name of the pointer variable. So what the meaning of this is, we have created a pointer variable called ptr, which can store the address of any floating type variable. I will repeat, star ptr means what? We have created a pointer variable which can store the address of a floating point variable. So that is the meaning of that. And we have a mean variable to store the mean value, that is also float, and std is the standard deviation, and for calculating the sum we need the sum variable, and initially that value is set to 0. And another variable I want is sum std. What is the sum std? That is also set to 0. I showed you here, we have to find sum of the difference with the mean. So d0 minus x bar square, d1 minus x bar square, d2 minus x bar square, so on dn minus x bar square. All those are squares have to be summed up, right? For that I am using one variable sum std, and I will give an initial value of 0. And I have one more variable, floating point variable x. And also I have two more variables of integer type n. N gives the number of elements, how many elements user wants to give, that is stored in n, and I is used for the as an index for the for loop. Okay. Now we have the printf statement. Printf, enter the number of elements. So this will be printed so that user get a prompt saying that he needs to enter the number of elements. Let us say user wants to enter 10 elements in an array, so he will give the input as 10. Next statement is scanf bracket inside the two double quotes %d comma ampersand n. Ampersand is address of the variable n. So whatever the user gives, it is stored in the variable n. So if user gives 10, now after this statement is executed, n value is set as a 10 followed by a semicolon. Now after user gives 10 elements, we have to read those 10 elements in an array. So first we will prompt the user enter the array elements. So user will be prompted to enter the elements. After that he will enter 10 elements. And how we are going to read the 10 elements? We know for reading as one dimensional array we need one for loop, and it will go from 0 to n minus 1. So 0 to n minus 1, so we will be reading all the n elements. In case of our example, n is 10, so it will go from 0 to 9. 0 to 9, those 10 values we are going to read in a loop. So for I is equal to 0, initially we will set it to 0, 0 less than n. So we will take 0 less than 10 true. It will come here scanf %f. Why %f? We know the array is holding floating point data type values. So all the float values are there. So we need to have %f format specifier inside the two double quotes comma ampersand a square bracket I. So what is the initial value? 0. So a of 0. at 0th location first element will be stored, and it moves to the next location 1, then scanf ampersand a of 1, it will move to 2, we are going to read ampersand a of 2. So we are going to read each element one by one by increasing the index. How long we will read? Until we reach a I value reaches n minus 1. So we are going to read up to n minus 1. If it is the example is user has given 10 numbers, that means we are going to read it from 0 to 9. So 0 to 9 elements will be available in the array. Now first how we will read the value. Now already array is set with the elements, and all the values are stored in that. Now we want to read the array and find the sum. First step is, what we have to do is, we have to set the address. What is the PTR? PTR is a pointer variable. It is PTR is equal to a semicolon. What is the meaning of this? Means a is what? It's an array. The name of the array itself is the address. Okay, address of the array. So that address is stored in PTR. If you remember in the diagram I told, the a name, the whatever the array name means, it is the address of the first location. So address of the first element. So address of the first element is stored in PTR, pointer variable initialized with the address of the array. So now we have stored the value address of the beginning of the array, that is stored here. Now we will loop through. How many elements are there? N elements are there. We have to loop through 0 to n minus 1 to access all the elements. For I is equal to 0, I less than n, I plus plus, we will come here. Sum is equal to sum plus star PTR. When we use star PTR, first is sum. What is the value of the sum? Initial value is 0. 0 plus star PTR. What is the meaning of star PTR? The meaning of the star PTR, PTR is having a address of a particular memory location. When I say star PTR, it will get the value that is stored in this address location. Is that clear? So what is star PTR? Star PTR means PTR is storing the address of some memory location. If you see, we have started PTR is initialized with the initial location of the array. So in the initial location of the array, whatever is stored, that value is will be extracted. So in this example, star PTR means it is D naught. It will get a D naught value. That is the star PTR. It will get D naught value, and that value is added to 0. So sum will become D naught. Then pointer plus plus, which is also means PTR is equal to PTR plus 1. Meaning what? We are moving this pointer to the next memory location in the array. So earlier my pointer was addressing here. Now we moved it to the next memory location. If I say plus 1, it will come to the next array element. It will come to the next array element. I plus plus, I less than n. When it is true, sum is already D naught. And what is stored in the next memory location? Star PTR. Now PTR address is pointing to the next memory location. It is pointing to next memory location. What is stored there? D1. So it will get the value of D1. So sum will become D naught plus D1. Now pointer will be incremented again. It will point to the next memory location. In the next memory location, a value of D2 is stored. Again, this when it comes to the loop, sum is equal to sum. What is the sum? Earlier D naught plus D1. Now this pointer is pointing to the third element, that is third element here is D2. Already we have D naught plus D1. Now it is pointing to this address. So star PTR will give me D2. So that is d2 is extracted. So sum becomes d0 plus d1 plus d2 and so on. So this will go up to n minus 1. What is the n minus 1 value? N minus 1 is dn minus 1. So it will keep on adding. We get the dn minus 1. After that I value becomes n less than n false. Then we come out at the end of this particular loop. We have moved through all the array elements and we have found the sum. So since sum is available, mean is calculated as mean is equal to sum divided by n. That is the sum divided by n is what? That gets the mean value. Okay, mean value or average value, sum divided by number of elements. So this part is done. Now we have to find the standard deviation. If you see here, we move the, now where the pointer is pointing, at the end of this it is pointing to the last location. It has passed through the last location. Now what we will do is we will again, so when the first time the looping happened, the address PTR was addressing to this point, then again we will point it back to the initial location. That initial location is A. The name of the array itself is the initial memory location. PTR is equal to A, pointer variable initialized with the address of the array. Now for I is equal to 0, I less than n, I plus plus. So we will loop through all the array elements and we have one more variable x. Okay, x is equal to star PTR. Initially it is pointing to the, initially it will point to the this location. Why it will point to that location? We have said PTR is equal to A. So initial location, this is a d0, d0 minus mean. So mean we have calculated, d0 minus mean is, this value is stored in x, and sum std is equal to sum std plus x into x, x square. So we are getting square of this. And what is the initial value of sum std? The initial value of sum std is set as 0, right? Now what is the value we are going to get here? Sum std is equal to 0 plus x square, that is d0 minus mean, that is square. Then this pointer is incremented by 1, PTR is equal to PTR plus 1. So this will move the address to the next location. When it is moved to the next location, it will point to D1. Now the value will become in the next iteration x is equal to star PTR. PTR is pointing to the next array element, and what is the star PTR? Value stored at that location, that is D1 minus, okay, x is equal to D1 minus mean. And sum std was what? Previously it stored D0 minus mean square plus x is D1 minus mean into D1 minus mean, that is D1 minus mean whole square. So repeatedly we will calculate this and we keep on moving the pointer to the next location. So we complete through all the location. When we are at this point, what we get is dn minus 1 minus mean square. So we will be getting the complete, the numerator sum will be stored in sum std. When this loop completes, sum std, the numerator part will be available. Then what is the standard deviation? Standard deviation is a square root of sum std divided by n. So square root of sum std, whatever the sum, divided by n. So we are going to calculate. This is the sqrt function used in the program, and numerator is sum std divided by n. And I already told you sqrt is the function that is available in the math library. So at this point we have calculated the standard deviation. We are going to print all the three values. printf sum is equal to %f new line. So we are going to print the sum. Mean is equal to %f, mean is stored in the mean variable, and printf standard deviation is equal to %f. std variable stores the standard deviation. That is how the program will print the three values, and we will see the output here. Output, when you compile the program and if there are no errors, then execute the program. Then after running the program, you get a prompt, enter the number of elements, and you give the number of elements as 5, and then it will prompt you for enter the array elements. And what will be the array elements? You will let's say user enters it as 2, 3, 4, 5 and 6. Then your program will calculate the sum. What would be the sum? 2 plus 3 5, 5 plus 4 9, 9 plus 5 14, 14 plus 6 20. That is how we get the 20. And mean is what? 20 divided by 5. 20 divided by 5 is 4. And standard deviation, using that formula you can calculate, you can cross check whether this is correct or not. You get a value of 1.414214. that is the standard deviation. Now let us see the flowchart. Okay, so let us quickly go through the program so that you can understand the flowchart easily. So what we did here, initially we did all the declaration, initialization of the two variables, then reading the number of elements, then reading the array elements in a loop, then we are setting the pointer variable to the beginning address of the array, then we are looping through the array elements and adding the pointer value to the sum. So at the end of this we get all the sum of those array elements, and we calculate the mean. Mean is equal to sum divided by n. Then again for calculating the standard deviation, again we start from the beginning. Pointer is set to beginning of the memory location of the array. Then we move through the complete array list and we find the pointer, the array element minus mean, that is d0 minus mean, d1 minus mean, d2 minus mean, all those, and we find square of that, and we find the sum. We will sum all the squares. When this loop completes, we will find out what is the sum. Then standard deviation is square root of sum std divided by n. That is how we find all the three values. Now compare this with the flowchart. This is the beginning, start of the program. Okay, start of the program. Initialize sum is equal to 0, sum std is equal to 0. Then next step is read all n elements into array. So read all the elements. So we have used here, this is the part, read all the elements. So for loop is used. You need not use a for loop. You can just say read all n elements into array. Then next step is what? Store address of first element in pointer, that is ptr is equal to a. So this statement, we are at this statement. This statement, what is the meaning of that? Store address of first element in ptr, that is ptr is equal to a. Then we start with the loop, set I is equal to 0. Now I is equal to 0 and we loop through all the array elements. If I is less than n, then what? If answer is true, sum is equal to sum plus value at address in ptr. So ptr is having a address. Whatever is the address that ptr is storing, what value is stored there? That is a star ptr, that is a d0. First element is d0, that we are going to add. Now ptr plus plus means what? Move to the next address and store it in ptr. Then I is equal to I plus 1. So this will loop back and the condition is checked again. If I is less than n, if all the elements are not yet complete, it will come here, it will find the next value, okay, it will add it to the sum, move to the next address location, increment I is equal to I plus 1, then it will do this in a loop, okay, and it is this, okay, this is in the loop until this condition is true, I is less than n. When this condition become false, it will go and calculate the mean. So when this condition is false, it will come and calculate the mean value. You can see the mean is calculated, and after calculating the mean, again initialize the pointer variable to the beginning of the array, that is ptr is equal to a. So after mean is calculated, we are setting the ptr to a again, and we have one more loop where we will find the square, sum of squares. So this will join to the next page with the connector a. Okay, this is the next for loop for standard deviation. I is equal to 0. If I is less than n, if the answer is true, x is equal to star ptr minus mean. What is star ptr? Value at address stored in ptr. So ptr is having an address, what in that particular address what value is stored, we are going to get that minus mean value, and sum std is equal to sum std plus this x square, and we will move to the next ptr plus plus, ptr is equal to ptr plus 1, it is same as this. We move to the next address in the array element, I is equal to I plus 1, we will check whether I less than equal to n. If I less than equal to n, until all the array elements are complete, we are going to find the array element value minus mean, and here we will square it and add it to the sum std. So and then move to the next memory location and so on. So this second loop, this loop will continue as long as I is less than n. When this condition becomes false, what we are going to do, we are going to calculate the std. Okay, when this condition becomes false, okay, so when this condition becomes false, what we are going to do is calculate std is equal to square root of sum std divided by n, and after that what you are going to do, after that you are going to display some mean and standard deviation values, and then your program will stop. So that is the here. So after that we are going to display some mean std, and at the end we are going to stop. That is the end of the program.